Cam. I gave Cam a challenge a little while ago, and he has finished that challenge, and he would like to share the results with everybody.
Do we want to real quick just yank a winner for the other drive?
Did that finish?
Yes.
I'd like Cam to do that while I yank the winner for the other.
Okay.
drive.
Sounds good.
Okay.
Yes.
So we're going to go over the document
Oh, you did?
here.
Yeah.
Did you announce it?
Oh,
Yeah,
wait, we
spell
did.
Cam,
Oh,
please.
okay, never
The Black
mind.
Lotus thing,
It's fine.
sorry, quick. Dosa won the Black Lotus cross stitch. Congratulations.
Dosa!
That made $1,381.76. Thank you so much.
Nice.
Let's get Cam on document Cam.
Fantastic. Okay.
Oh, okay.
Good
Actually,
job.
can we get the microphone over here?
Yes. Hang on a second.
There's a table mic there.
There is a table mic?
They'll be able to hear you.
Okay. You can hear me?
Just like.
Yeah.
I've never seen it like that.
Let's just
I've
keep going.
never seen it like that.
Neither does anybody else. I wouldn't worry about it.
Did something fall over? Is something moving?
Everything is fine.
Okay, everything's fine. Good to hear.
We can get started on this.
There's a lot of other stuff happening.
At your leisure, I think, Cam.
Yeah,
Okay.
we've got you on skill cam.
So, I was challenged by someone who's having problems with the inverse, finding the derivatives of the inverse functions of the basic trig functions.
Yeah.
So, I mean, I haven't done this in years. You just kind of look them up when you need them,
That
right?
makes sense.
But if you're actually like working on why and how they work, then you actually need to be able to go back and figure them out. And I'm like, oh, I can do that. 2 hours later.
Okay, all right.
Yeah. Okay, so when you're looking at inverse functions,
That's how I saw it.
you need a few basic tools at your fingertips. What's an inverse function?
I think you may need to go up to a full Sharpie.
Oh?
And go bigger.
Do we have a Sharpie?
Okay.
Yeah, there's
Well-
a Sharpie behind you. Hang on.
Actually, so we've got, say we have, we want to know what the derivative of a function is.
Give me the Sharpie.
Y equals root of x. Can we see that at all? No? Okay.
Go Sharpie, go large.
Get some extra paper. You might need to move to another piece of paper too.
Y equals root x.
That shows up much better.
Very
Okay.
nice. That's totally clean.
So the inverse function of that is x equals y squared, right?
Right. Yeah, that makes sense.
Okay, right, they operate, if you label this one f and this one g, you can see that if you do f operating on g, right, you get g operating on f, right? They cancel each other out. Oh, have I mentioned it's 4 in the morning?
Five.
Is it fair to say they're identical, in fact, you've got 3 lines?
Yeah.
There we go.
So, okay. Now, say we want to find out the derivative of this. As it turns out, you can do a thing that maybe your prof told you about, where the derivative of an inverse function is equal to the reciprocal of the derivative of the forward function. Basically.
Sounds good.
Okay.
Yeah, so if we want to know what the derivative of the root of x is, we can take the reciprocal of the derivative of y squared and then substitute it back in. Right? So,
That's 1 over 2y?
yeah, exactly, Beach.
Yeah, okay.
So the derivative of y with respect to x is equal to 1 over the derivative of x with respect to y of y squared,
Okay.
which is equal to 1 over 2y. And if we go back up here, we can see that y is equal to root x. So we just substitute that back in.
Like you do.
1 over 2 root x.
Yeah, which is correct, right? The derivative of root x is 1/2 of x to the negative 1/2,
Neat. Okay.
Right.
right? Okay,
Correct. Cool.
so before everyone's eyes glaze completely open and the number of viewers drops to the one person doing the challenge,
Absolutely.
we're going to look at the derivative of Arcsin.
For those of you, for whoever it was who donated to have Cam show this off, I want to see you kick in soon, I hope.
So arcsine theta, say that's equal to y. That implies, because it's an inverse function, that sine of y is equal to theta, right? That's kind of how it works.
Right.
Okay,
Right.
so by putting it into our formula here,
One second. You guys, Jason has to go back to Texas right now.
Right
Can we
now?
get the room quick?
Room Cam, quick.
His taxi's outside, but he has to go back to Texas right now. He's on his way to the airport, so he's gonna say goodbye to Dodger Bus.
Bye,
Bye, Jason.
Bye,
It's
Chad.
lovely having you here.
Thank
We
you.
love you.
Please come back next year for longer.
Yes,
Enjoy
hopefully.
BBQ.
And I hope the project that I'm working on turns out. I'm sure most of you guessed what it is already. If not, whatever. And I'm going to use my words carefully so Kate doesn't yell at me. Hope I see some of you at PAX South.
Thank you.
PAX South.
PAX South.
Yeah.
Not another thing. Not another thing. Not going to say it.
Mikey.
PAX. All right. Bye.
Bye.
Thank you.
See you,
no
Jason.
worries.
That
All
was
right.
bad.
Cam.
Okay, back to math class,
Yes.
everyone.
I'm working it through.
You
Okay.
thought you could escape.
So if we want the derivative, ddx, dy dx, d theta, oh god, my hands are shaking, I'm so tired,
That's all right.
You should probably go home.
right? dy of d theta of arcsine theta. These are letters and symbols that have meaning to me. We can say, by our formula over here, that this is equal to 1 over d theta dy of sine y.
It's
And
because we have to take the inverse of this.
Yeah,
Yeah.
and the
okay.
derivative of sine, the derivative of a sine is cosine, right?
Oh yeah, right, yeah.
Yeah,
We know that.
so we're looking at 1 over cos y, which is utterly useless to us. We've defined the derivative of a function in terms of its opposite. So now we need to substitute this back in,
Okay.
right? We need to define this in terms of theta and not y. So we're going to use one of our good old identities from like grade 11 trig, maybe grade 9 trig. Sine squared plus cosine squared equals 1. And we're going to substitute that in. We're going to solve that for cosine of y, right? So cos y is going to be 1 minus sine y, and we take the square root. Right?
Right.
Okay.
I'm following
Oh,
still.
man.
So we substitute this back in here, and we get 1 over 1 minus sine y, which is still not in terms of theta,
Okay.
but we have sine y defined in terms of theta up here,
Right. Yeah.
right? So we label this, we'll call this 1, and we put 1 in here.
You're saying something about sine up symbol to
Sine,
y?
it's a sine squared y. Is what,
Yep.
is what they're saying in there. Somebody's saying
Oh yeah, sine squared.
1 minus sine
Yeah,
squared.
sorry.
Yeah.
Yeah, this is sine squared y.
I like that there's people in chat who know what's going on. So
So-
this is fascinating.
This turns into
This is
1
why calculus is fun.
over 1 minus theta squared.
Yep.
And we take the square root, which should be, that should be what you see in your textbook. Now, we can pull the same trick with cosine, only with cosine, we find when we run through the numbers, the derivative of that is the negative of this.
Oh.
And tangent gets messy fast.
Do you think it's a good idea to show it, or do you think we should just we should show a final result later, or do you want to work it through? Can it take a couple minutes?
It can take a couple of minutes if people aren't.
For tangent, your professor has office hours.
Well, no, tangent, what you do is you work it through the same way,
Right.
but what happens is you wind up with, oh, okay,
5 a.m.
arctangent, okay? Theta equals y, which means that tangent of y is equal to theta. So we put it into our formula from over here, and we wind up with the derivative of y with respect to theta is equal to 1 over 1 over cos squared y. Right, because the derivative of tangent is cosecant squared.
Okay.
This is a mess to work with.
'Cause
We
it's-
have no substitution for this,
That's-
right? Because if we try to define these things in respect to one another, we wind up canceling them out. So we want to run all the way back to what we know these things actually represent, right? So if we've got an angle over here called y, and we've got, this is the hypotenuse, this is the adjacent side, and this is the opposite side. We can label this one as being of length 1. This one we have no idea, it's x. And this is equal to 1 plus x squared to the 1/2, right? That's just good old Pythagoras,
Right.
right?
Yeah.
Old P-tag.
Yeah. So now we can actually substitute that in, right? Hypotenuse SOHCAHTOA is adjacent over hypotenuse cosine squared. So this goes in here, and you wind up making 1 over 1 plus x squared, which is what it should have in your textbook.
All right.
Fix that. Okay.
Is that,
Yeah,
Is that the final?
did we
That's-
live?
that's it. Those are the
We
basic.
did it.
Those are the basic trig functions.
Hooray!
That is as close as we're going to be able to get to doing any more of your homework.
All right. So,
But congratulations that we worked that out, and thank you, Cam, who has had to do this at 5 a.m.
if you're into math, surely that's worth a donation.
So Cam,
Speaking
Yeah.
of,
are you gonna have a podcast now where you do 5 a.m. homework for people?
Go to Khan Academy, not Cam Academy.
It's like the My Drunk Kitchen meets Underslept Cam meets Khan
Yeah.
Academy.
No, as one of my profs told me, there's nothing you can't work out with a sharp pencil and a pot of coffee. Right? Like,
That's fair.
You know what your podcast name needs to be?
what?
Zeta Functions.
No. All right, we got to move on here because it's 5:05.